So the rule that we're going to work on now is called the chain rule, and it really is the most important of all the rules we're going to deal with for derivatives. And we're going to take a really, really simple case of a function that we know how to take the derivative of and break it up into two different functions, so a composition of two different functions, and see if we can find a relationship between the composition functions and the original functions in terms of their derivative. Because the chain rule is going to allow us to take the derivative, let's say, of something like sine to the fifth of x really easily, rather than having to write it out as sine x times sine x times sine x times sine x times sine x, and then using a bunch of different applications of the product rule to do that. The chain rule is going to let us do that very simply, very easily, and give us a much more simplified answer. So the chain rule is going to be our trick for when we can write our function as a composition of two other functions. So we're going to start with a real easy one, 6x minus 10. We're going to write this as a composition of two functions. One of those functions is going to be y equals 2 times u. So the reason I chose 2 times u is I can factor a 2 out of this original thing, right? 2 times 3x minus 5 is what y is equal to. So if y is 2u, what is u equal?
3x minus 5.
3x minus 5, exactly. So everybody see that I've written my original function, 6x minus 10, as the composition y equals 2u with u equal to 3x minus 5. Everybody good with that?
Yes.
Okay. So my first question then is, what is dy dx? That's the derivative with respect to x of the function y when it is written in terms of x. So that's the derivative of 6x minus 10. And what does that equal?
6.
6. Good. All right. So what is dy du? Well, it's the derivative of the function y when I have it written in terms of u. So it's the derivative with respect to u of 2u. What's the derivative of 2u in terms of u?
2.
2. Good. And then lastly, I want to know, what is du dx? Well, that's the derivative with respect to x of the function u, which is 3x minus 5. So what's that derivative?
3.
3. Good. Anybody see a relationship between those three numbers?
2 times 3 equals 6.
Wow, amazing. Very good. So, yeah, 2 times 3 is 6, right? If we take the individual derivatives of the two pieces of our composition, so dy du and du dx, and multiply them together, we got the derivative of the original function. That idea that dy dx equals dy du times du dx is called the chain rule. That is one of 3 basic notations for the chain rule that that you will get used to seeing. Okay? Dy dx equals dy du times du dx. This rule right here. You will memorize that as the chain rule. We will also see it occasionally in this form, but also very often in this form. We won't deal with this this form, f prime of g times g prime, very often today, but we will deal with that a lot as we move forward this year. And then this one, f prime of u times g prime, we won't see that one super often. But we'll see this one, dy dx equals dy du dx for the rest of the day today. We're going to use that notation for it to find the derivatives of a bunch of other functions that we can use the chain rule for. Any questions or any issues as of right now with that first problem and this being our formula that we're going to use for the rest of it? No? Okay. So we're going to take a simple one here, another fairly simple one. Y equals 3x squared plus 1 to the second power. And we're going to use the chain rule to find its derivative, and then we're going to use some other methods to check and make sure that it works. So let's start with the chain rule. So in order to use the chain rule, we have to write this as a composition of two other functions. One will be y equals something in terms of u, and the other one will be u equals something. So how can we break that up?
You could do y equals u squared and u is equal to 3x squared plus 1.
Perfect. Everybody agree that if y equals u squared and u equals 3x squared plus 1, then we get y equals 3x squared plus 1 squared?
Yes.
Okay, so what's dy du?
Two u.
And what's du dx?
6x.
Everybody good with 2u and 6x there? Okay, so what is dy dx? Well, dy dx, which is dy du times du dx, should be 2u times 6x, or 12x u. And since our original equation was all in terms of x, we'd like to resubstitute out this u and get 12x times our original u, which was 3x squared plus 1. Everybody good with that? That's the chain rule. No questions there? All right. Now, let's verify that that answer is right. We could rewrite this as 9x to the 4th plus 6x squared plus 1, couldn't we? Just by distributing 3x squared plus 1 times 3x squared plus 1. You guys agree with that?
Yes.
Okay,
Makes
so
sense.
what's the derivative of this? It's 36x cubed plus 12x. And if I factor a 12x out of that, what do I get? I get this, right? And which way was probably easier? Probably the method we did in red there with just distributing it out. It's probably easier than going through and using the chain rule. But suppose that had been 3x squared plus 1 to the 10th power. It'd be a lot easier to use the chain rule, right? Rather than have to multiply out 3x squared plus 1 times 3x squared plus 1 10 times, and then use the power rule. So the chain rule is going to be very, very useful to us. Any questions or issues with that? All right, let's do another fairly easy one that we can verify using another method. So we're going to try and find the derivative of f of x equals the sine of 2x. So if I write this as y equals something in terms of u and u equals something, what should those things be?
Y is equal to sine of u, u is equal to 2x.
Yep, exactly. Sine of u with u equal to 2x. If I plug in u equals 2x, we get sine of 2x, which is what our original function was. So what's the derivative of y with respect to u?
Cosine u.
Exactly. So cosine u, and what's the derivative of u?
2.
2. So we get 2 cosine u, or 2 cosine 2x. Pretty straightforward. Okay, could we use a trig identity to rewrite sine 2x? What's the double angle for sine of 2x? Should have that
Cosine
memorized.
x, cosine x.
Exactly. Yeah, that was on that sheet. I told you to memorize all of them. 2 sine x cosine x. So how would I find the derivative of 2 sine x cosine x? Well, there's a function times another function, right? I could use the product rule. 2 sine x is one function and cosine x is the other one. So we'd have 2 times of x is equal to 2 sine of x times the derivative of cosine, which is negative sine, plus 2 cosine x, which is the derivative of 2 sine x times cosine x. And if we factor out the negative from both of those, sorry, not the negative, the 2 from both of those, we got 2 times negative sine squared x plus cosine squared x, or 2 times cosine squared x minus sine squared x. And from that sheet of all those formulas I told you to memorize, you should know that cosine squared x minus sine squared x equals cosine 2x. And we'll note that that is exactly the same as what we got over there. Everybody good? Any issues?
How did you like do 2 cosine x times the derivative of 2 sine x? Like in the first step?
Up here?
Yeah.
Yeah. So we did, so our u function is 2 sine x and our v function is cosine. So I did u, 2 sine x, times the derivative of v, which is negative sine x, and then plus the derivative of 2 sine x, which is 2 cosine x, times the cosine x, using the product.
Oh, okay.
Does that make sense?
Yeah.
Okay, cool. Any other questions on that? All right, let's take a look at this one. We've got an object moving along the x-axis, and we're given its position function at any time t greater than or equal to 0. That position function is cosine of t squared plus 1, and we want the velocity function. So if we're trying to go from a position function to a velocity function, what is the step that we need to take?
Taking the derivative.
Right, the velocity function should be the derivative of our position function. So we'll take the derivative of this, we'll rewrite it as y equals what? With u equal to what?
Y equals cosine u, and u equals t squared plus 1.
U equals t squared plus 1. Okay, so the derivative of cosine u is negative sine of u, and the derivative of t squared plus 1 is 2t. And so what is our velocity function? It is 2t, negative 2t sine t squared plus 1. Good or no? All right, you guys do this one on your own, and then we'll check and make sure you got it correct. So how did we write this function? Should have been enough time, I think. Y equals
Sine of u.
Minus
sine of u with u equal to x squared plus x, right? Which should then give us cosine of u times 2x plus 1, or 2x plus 1 times cosine of x squared plus x. Good or not?
I have a question. What does the differentiate mean?
Differentiate is just take the derivative of.
Oh, okay.
Yeah, sorry, maybe I haven't said that explicitly. So yeah, differentiate just means take the derivative of. All right, let's do a couple more. Let's do f of x equals root x squared plus 1. So how are we going to write this out? Y equals
Square root of u.
root u with u equal to x squared plus 1. And what is dy du if y is root u? That's one I told you guys to memorize, right?
One over two root u.
1 over 2 root u times just 2x, right? And the 2's will cancel, and we end up with x over root u, or x over root x squared plus 1. Any questions or problems with that? Everybody good there?
Are we allowed to leave a radical in the denominator?
Most certainly that is perfectly fine. I know all of your previous math teachers have been like, rationalize the denominators, or else, you know, your life will end. No, I don't know why everybody thinks you should rationalize denominators. They're fine how they are. Even if it's like, you know, 5 over root 2 is your answer, I don't care. Leave it as 5 over root 2. How is that any worse than 5 root 2 over 2? It's not. So just leave it however you want. All right, why don't you guys give this one a shot on your own, and then we'll talk about it. How'd that one go? You guys finished with that one?
Yes.
All right. How did you break it up to begin with? Y equals what?
I did u to the -3.
Right. U to the -3 sounds good. You might have done 1 over u cubed and then used the reciprocal rule. But u to the -3 is probably the way I would do it, just using the power rule. So y equals u to the -3 with u equal to 4x squared plus 6x. Everybody, oh, sorry, -7. Can't forget that. Everybody good with that?
Yep.
All right, so dy du should be power rule -3u to the -4 times the derivative of u, which is 8x plus 6. If you want to factor the 2 out of that, go ahead, but there's no reason to particularly. So this becomes -3 times 8x plus 6 all over u to the 4th power, or 4x squared plus 6x minus 7 to the 4th. Any questions or issues? Did you guys all get that as your derivative? All right, let's see. Yeah, I feel like that's a good place to stop. We will stop there and pick up tomorrow, finishing up the chain rule.